Hey guys, welcome back. Today we're going to be solving LeetCode question 721, accounts merge. The concept behind this problem is really nice. The only problem I find with this problem is the problem statement itself. It's very wordy. Like if I ever saw this in an interview, I would just be lost in the problem statement itself. It's not easy to read at all. So just a disclaimer, today's video is going to be long because the code itself is a bit longer than usual, and I'll spend some time in explaining the problem statement and in explaining the approach to the problem. Cool. So what they're saying is they'll give us an array of arrays. Cool. So this is also, let me just mention that this is a DFS problem. Like it didn't strike me as a DFS problem the first time I read it, but now that I have solved it, it's a DFS problem, and it's actually a good problem. It's based on the concept of connected components of a graph. If you don't see it going there yet, that's fine. We'll get there. It's So what they're saying is we have an array of arrays. Every array, the first element will be the name of an account. I'll probably use the terms name and account interchangeably, so don't get confused with that. But the first term will be a name, and the rest of the entries in the array will be the email addresses associated with that name or that account. Now, what's the catch of this problem is that there it is possible that two arrays will share an email address. Okay, like as you see here, John Smith and John Smith, that these two emails have been shared. Even though the other emails are different, that's fine. But this email is shared between two accounts. Now, if that ever happens, we can definitively conclude that they belong to the same person, the same account, the same name. So what they want to do is to merge these accounts, and this is possible for multiple such arrays. Like multiple arrays can share email addresses, not the same email address, but like what I mean to say is there can be one more entry for John, but the shared email address is this one, John New York one, and then there's some abc@mail.com, some random second email. So this sharing can happen between multiple arrays, but our task is to combine all these arrays into one array for John. Now, what is one more catch in this problem is that names can be shared among different accounts. Like as you see here, the second John does not belong to these three Johns. So what we can say is this is a different account. For an account to belong to the same person, they have to share at least one email. If there is no sharing of emails, like this Johnny Bravo is not shared with anyone, we can definitely say that just John, the second John, is different than the first, third, and fourth John, right? And that happens in real life as well, right? Like the same like there can be multiple accounts with the name Rahul, but they all have different email addresses. Cool. So this is the problem, and we are supposed to just return the merged. We are just supposed to return all the email addresses that belong to the same account in one master array. Now, how we order the accounts themselves doesn't matter, but the email addresses have to be sorted alphabetically. That is trivial. We'll handle that. Cool. So the concept is based. I don't know if you've solved the problem number of islands, but that is in fact a very important problem. If you haven't solved it, please do solve it. It's a very important coding problem, and it's based on the similar concept. It's not the just this concept is similar. The structure of the problems is very different because in number of islands you have a 2D matrix with zeros and ones, and you're supposed to return the total number of um, disconnected islands of ones, right? The What's different in this problem is that we actually create the islands because As you see, this is not a graph problem, and we are going to create a graph. We are going to create these islands, and then we are not going to return the total number of islands. We're actually going to return the distinct members of each island. Okay. And if you think about it, the every island will have email addresses for one account. That's how we're going to build the graph. Now let me just explain to you how that will go. So what we'll do is, for now, ignore the first names. Okay, these, just imagine you have an array of arrays of emails. Okay. um, Now what we'll do is, for every emails array, we'll connect an edge. Think of every email address as a node in a graph. Okay. Every unique email address as a node in a graph. What we'll do is, we will connect the first email address to all the remaining email addresses. What I mean by that is, if there are 10 emails, we'll have 10 nodes. We'll create an edge from the first node to the second node to the third node to the fourth node to the ninth node. So basically, we'll create 9 edges. We will not create any more connections. We can, but that is unnecessary. You will understand that part, but for now, just follow me. We will just create an edge from the first node to all the other nodes, and then we will keep on doing this for all the email addresses. Now, if you think about it, if any email address is repeated, it will automatically get connected. Meaning, let's say this John Smith has, okay, my battery is running low. This John Smith, say, has this John Smith node has connections to 9 other email addresses, 9 other nodes. There's only one other, but just assume for the sake of argument. And this John Smith, again, in a different emails array, has a connection to John New York. So what will end up happening is, we'll create a 10th edge for this John New York, but it will be connected to the same John Smith email which was used in the first emails array. So as you see, if we keep doing this, we'll keep on adding email addresses to this cluster for that John account, right? And that is how we'll create the graph. And if you think about it, this the cluster of emails for Mary will never be connected to the cluster of emails for John. And eventually, it comes down to a DFS problem. We'll start DFS in a we'll start DFS in one of these clusters. We'll retrieve all the unique emails in that cluster, and we can be sure that they belong to the same account, and we'll just put that in the array. Actually, if you think about it, if you're comfortable with DFS, the catch in this problem is just to actually create the graph. Even if you're not comfortable with DFS, it's fine. But once we create this graph, we are just going to start doing DFS in every cluster, collect all the emails in that cluster, and then we just have to do a mapping of what account these emails belong to. That is a trivial part. That is, we'll do that we'll do that easily when we start coding. It's important for you to understand the um, concept. It's also important right now for me to connect my charger. Sorry about that. Okay, so yeah, so we're going to create these clusters, run DFS inside all these clusters, collect all the emails, and then create a result. What result? Array of arrays. That's about it. That's the concept of this problem. And we'll use an adjacency list to create the graph. If you're not familiar with the adjacency list, please do read about it. And there's actually nothing more to explain as far as the concept of this problem goes. So I'm just going to start coding. It's a long code, so I'm going to explain in detail while I code. But as far as the theory behind this goes, there's nothing to add. So I'm just going to start coding. Cool. I'll remove this because this does not really add much anymore. Cool. Let's start. So as I said, we are going to create a graph. Okay, so um, we will, and our graphs are email addresses. In terms of this problem, they are strings. And as you know, when you structure a graph as an adjacency list, we have every node, and every node is associated with its neighbors, with an array of nodes which are its neighbors. So this string will be one email address, and these strings, the array of strings, will be all the emails that it is associated with. Okay, cool. Now for every account in accounts, okay, meaning, actually I think I'll just keep this here. It actually might be useful in explaining as I code. Okay, so this is the entire account. Let me comment this out. So this is the entire accounts array, and when I say one account, it's one array. Okay, please bear in mind that this account is one entire array. Okay, don't get confused in that. Cool. So what we'll do is, let's first extract the name. Okay, because the first element of every account is the name. Let's extract the first email, because we are going to connect the first email to the rest of the emails as we discussed earlier. Let's just get that out. Okay, and then we can we'll just so what I'm doing here is I'm just removing the first element of the emails array, meaning I'm just dropping this name. Okay, and I'm just going to process the rest of the email. This is just for convenience. I mean, you can choose to do whichever way you want. I'm just drop first will just remove the account name and leave me with just the emails. That's what I'm doing here. Cool. So what we'll do is, for every email, oh okay, so I'll just create a helper function to add an edge in the graph, passing the graph. Ignore the in out, it's just a string, it's just a Swift keyword. It's for use for passing by reference. If you're unfamiliar with it, don't be bothered by it. It's not important. And I mean, it's important, it's not important to the solution right now. So just creating, okay. Also ignore these underscores. Again, just a Swift syntactical sugar types situation. Okay. So what we'll do is, if we already have some entries for this node, if we already have some neighbors for this particular node, we'll just append the new node to that existing neighbors array. Otherwise, we'll create a new neighbors array. It's fine, you'll understand this. I've seen one-liner codes for this in Java, but I'm sure internally they do the same thing. Okay, let me just code it out. You'll understand as I code. Neighbors dot append to, and then graph of from to, we assign it back. Okay, if there are no neighbors yet, we just create a new array and put 2 there. Okay, so for every email, for every email, we add an edge from the first email. Okay, I need to pass the graph first. So from the first email to this current email, and we need to add an entry in that is how adjacency lists works. Adjacency lists work. We have to make an entry both ways. I mean, if you create an edge, you have to create an entry for the from node and for the to node. If you're familiar with adjacency list, this will not look difficult, but this is how adjacency lists work. So we'll create an entry both ways. Please rest assured, this is just creating one edge. We are just updating the entries for both nodes. That is just how adjacency lists work. Cool. And then okay, we also need to maintain. This is something I already know, which is why I'm doing it. Probably when you're naturally coding, you won't do this first, but or maybe you will do it first. But let me just tell you, it's important for us to create to to have a mapping from the email addresses to the actual account names. Okay, it is important. Let's just do that for now. Okay. So we'll add an entry. It is possible that an entry will be updated for the same email address multiple times, but the important part is we should know which account every email address belongs to. So even if it keeps updating, it will update to the same account name. So it's fine. Cool. And cool. So at this point, we would have created our graph. Graph created. After this point, after this point, we just need to process the islands using DFS. So what follows after this is just DFS. Cool. I'm going to do a recursive DFS because that's more intuitive to me. The LeetCode solution has done that using stacks, but I'm more comfortable. I've always done DFS using recursive procedures, so I'm going to do that. Cool. Let's have a visited set. It's going to be a set of strings. Let's create a result. I'm going to need that very soon. Okay. And then we return this result. Cool. Now let's do the DFS part. Actually, I think it would be better if I just write the DFS procedure first. This is going to be a long problem, right? Cool. We'll need the graph itself. No in out here, but don't be confused with that. It is just for passing. If you do in out, it passes by reference. Otherwise, it passes by value, and passes by value meaning you'll be working with copies. We don't need to delve deeper into that. It's fine. That's not important to the concept of this problem. Then, as is customary with DFS, we pass the source string. We pass the visited set, which is a set of strings, and we'll also keep a set to account for the to collect all the emails in this current cluster. Yeah, there's one thing I want to note here. One thing that I was going to mention, but I forgot to. So as you see here, this will create an edge, a self edge from the first email to itself. Okay, but that's fine. That's totally fine. It won't affect the solution. Okay, because it doesn't matter. The important part about this problem is all email addresses that belong to the same account have to be connected in some way. Okay, whatever multiple edges that they have within themselves doesn't matter. They have to be connected by at least one edge is the what catch. I mean, you can have self edges for all emails. You can have edges from the second email address to the third, not just the first to the rest. You can have from second to third, second to ninth, doesn't matter. They have to be connected in some way is the point. Okay, cool. Yeah, so we'll have a current set to keep a note. Let me create more coding space. Wow, my laptop has become really slow. Oh man. Okay. Set of string. This will also be a set of string. So I'm not going to explain how DFS itself works. I'm hoping you're familiar with that. Cool. So I'll just insert this in the visited set because we have actually just visited it. We'll also insert it in the current set. Yeah. And then current set, because current, please remember, current set is a set for only the emails in the current cluster, the current cluster that we are. So basically the John cluster. Mary will have
Something went wrong. Try again in a few seconds.
Sorry, that was my Google Home. We'll have a separate cluster for Mary and so on. Cool. So for every neighbor in as you know, adjacency list, when I do this, when I hash onto the graph dictionary, I get all the neighbors. So right now inside this for loop, I'm inspecting all the neighbors of the source. Okay. And if the neighbor hasn't been visited yet, I will visit it. So I'll pass the graph. The neighbor will be the new source. I'll pass the visited, passing by reference, and I'll also pass the current set. Yeah, that's just how DFS works. Then the neighbor will append, will, if it's not been visited yet, it will add itself to the visited set and to the current set. And this is all, like, this is all we need to do inside the DFS routine. Going back to the main routine. Okay, yeah. So for every key, yeah, so we need to only inspect the keys of the graph. We don't need to look at the values because that is something that the DFS routine will handle anyway. If we inspect all the keys in the graph, we'll in fact be looking at all the nodes in the graph, because every node has an entry in the graph dictionary. So we don't need to look at the values. So we will, okay, yeah, we will define a current set, and if visited does not contain the current key, we'll start DFS for it. We'll pass this new key, we'll pass visited. So please note that visited is updated by all clusters, which makes sense, right? I mean, it should be updated by all clusters. Like you don't want to revisit a cluster that you've already visited, but current set is reinitialized to an empty set every time you start inspecting a new cluster, because you need to extract all the emails inside that cluster. So that's why we create a new current set. This current set goes inside the DFS routine. It collects all the emails, and then I'll show you how to like put it in the result. Okay. So if current set did collect some emails, only then should we append it, right? What we'll do is let's convert it to an array, because we do need to return an array eventually. And then current result. Okay, this is where we are going to use this mystery dictionary. Okay, email to name. We can be sure that every email inside current set belongs to the same account. Okay, so we are just going to extract the first email address inside current emails and use that to map onto the actual account name inside email to name. That sounded confusing, but you'll know after I write this statement. So email to creating a new array. Basically, I'll append these current emails to this current result. You'll know. Email to name, just using the first. You could use any email inside current emails. Okay, I'm just using the first element, but you can use any email because all emails we are sure belong to the same account. Okay, let's do this. Ignore the exclamation mark Swift keyword. Um, yeah, that's about it actually. Oh, I'm sorry. The exclamation should be here. Now, just appending. So basically, right now at this point, current result is an array containing just the account name. After this point, I'm going to append all the current emails. Okay. Yeah. So this is how you concatenate arrays in Swift. One important thing, they want it to be sorted. As you can see here in sorted order. The accounts themselves can be written in any order, but the emails need to be sorted. So that's what I'm doing here. Just you using a Swift routine, built-in routine for that. And yeah, we'll just append this to the final result. We are edging really close to the final result, and that's actually it. We're done, yeah, we're actually done. I mean, you just append this. So after this point we would have concatenated the emails to the name, created the final current, like this current result is actually one of, say, this one. Okay, this is one current result. At some point current result will be this, at some point current result will be this. Now the orders of the accounts themselves is not fixed, but emails themselves are sorted. Okay, this is it. Just I'm going to submit the solution now. Okay, made some error. Let's see. Oh, I'm sorry. I need to declare these as an order. Okay. Awesome. Okay, that works. I hope I did a good job in explaining the problem. If you think my explanation was good, please do support the channel. The channel is very new. Please like, share, and subscribe. And happy lead coding. Stay safe. Take care, guys. Bye.